Let me know when you can see my screen.
It's visible.
Perfect. So, first of all, thank you so much to Pakistan user community for inviting me for this session. My name is Uzair Raja, and I'm working as a data warehouse specialist. And I'm working in the areas of cloud computing, databases, data warehouses, and business intelligence. And I'm based in Copenhagen, Denmark. And today I'll be discussing about database offerings in Azure. And particularly in this area, I'll be discussing about what are the SQL Server offerings in Azure, what are different purchasing models in Azure, and what are different open source database offerings that are available in Azure. I will also be discussing about Azure Cosmos DB, which is a kind of SQL, NoSQL database offering. And then the most interesting thing that I will be discussing in the end is the Oracle Database Services for Azure, which is a kind of a collaboration between Microsoft Azure and Oracle Cloud Infrastructure. Um, so if we look into this picture, which is from December 21, and it's from Gartner Magic Quadrant, you can clearly see that Microsoft is leading in the area of cloud database management system platforms. And when we talk about different SQL Server offerings in Azure, we have primarily SQL Server offerings that are available in two categories. We have infrastructure as a service offering, and we have platform as a service offering. And within infrastructure as a service offering, we can have SQL Server that is on a virtual machine. And within PaaS offering, we can have two types of SQL offerings. One is called SQL Database, Azure SQL Database, and the other one is called Azure SQL Managed Instance. Now, the primary use case for Azure SQL on a virtual machine is that you want to rehost your applications that are on premise and you want to move those applications to the cloud. And those applications require some kind of dependency with the operating system. So in this case, you will be opting for Azure SQL on a virtual machine. And you also have an option to host your Azure SQL either on a virtual machine running on Linux or a virtual machine that are running on Windows operating system. And this offering also provides you options to go for different versions of SQL Server, like you can go for SQL Server 2016, SQL Server 2019, and even you can go for SQL Server 2012. Since it is a Azure SQL on a virtual machine is infrastructure as a service offering, which means that you as a customer are responsible for everything like operating system upgrades, software upgrades, backups, and also for replication. Um, um, when we talk about the platform as a service offering, then we have two offerings, Azure SQL Managed Instance and Azure SQL Database. Now, the use case for Azure SQL Managed Instance is that you can use it for, you can also use it for lift and shift your applications in the cloud. And and you want to get rid of some of the DBA activities that you have to do on premise, like you want to have automatic backups, you want to have automatic software patching, you want to have database monitoring and other maintenance tasks that can easily be done. Then in this case, you will go for Azure SQL Managed Instance. The thing that you need to remember is that Azure SQL Managed Instance provides you with near 100 compatibility with the SQL Server on premise. Now, the word near 100 compatibility is very important here. um, when we talk about the Azure SQL database, which is another offering within the Azure SQL PaaS offerings, it is best for if you are developing new applications in the cloud, and it provides you with several kind of models. You can go for a serverless model, and you can also go for a provisioned compute model, and I will come back to it later. Since it is a PaaS offering, so you will get automatic backups, software patching, and database monitoring and other tasks. Before moving on with database offerings in Azure, there are two concepts that are very important to understand in this domain, and those are purchasing models that are used in the Azure. When it comes to databases, we have two types of purchasing models. We have a DTU-based purchasing model, and we have a vCore-based purchasing model. And DTU is actually database transaction unit. So it is a fixed measure, and it is a measure of CPU, memory, and storage. On the other hand, vCore in vCore you can differentiate between your storage and compute. So within the DTU, you have three types of service tiers that are available. You have a basic service tier that is for those workloads that are not memory intensive. Then you have a standard workload, and you also have a premium workload. And please remember that DTU based pricing model is only applicable to Azure SQL Database. Uh, since DTU is a measure, it is a number, which means that higher the DTU, the more powerful is your database. When we come to vCore, in vCore we have three types of service tiers that are available. We have general purpose, we have business critical, and we also have hyperscale. Now, please notice here that general purpose and business critical are applicable to both the PaaS offerings, which is Azure SQL Database and also to Azure SQL Managed Instance. On the other hand, hyperscale is only applicable to Azure SQL Database. And within the general purpose model, we have further two classifications. We can either go for a serverless compute, and we can go for a provision compute. And I will come back to it later. Then in addition to this, there are two other concepts that are very important to understand within the domain of vCore, and those are Azure Hybrid Benefit and Reserved Capacity. Uh, Azure Hybrid Benefit is a cost-saving benefit in which you can bring your on-premise existing Windows and SQL Server license to the cloud. And in this way, you can save a lot of money on the SQL Server licensing and also for the VM licensing. And Azure Hybrid Benefit is applicable to both the SQL Server database and also to Azure SQL Managed Instance. But if you are going for the serverless compute within the general purpose, then Azure Hybrid Benefit will not be applicable. In addition to it, in reserved capacity, what happens is that you make a commitment with Microsoft that you would use your SQL Server or Azure SQL Database or Azure SQL Managed Instance for, let's say, 1 year to 3 years. And in this way, you will get benefit, you will get cost reductions in licensing from the Microsoft. There is one thing that you should note is that if you start with the DTU model, you can switch to the vCore model. And if you start with the vCore model, you can switch back to the DTU model. However, if you start with the vCore model and you choose the option of hyperscale, then you cannot switch back to the DTU model because hyperscale is based on a different architecture. And I will come back to it later. Here you can see that in a DTU model, you have it is a fixed number. So your compute and your storage are tied together. So one of the drawbacks in a DTU model is that, for example, you are running a workload and you need more memory or you need more compute. And if you increase your compute, your storage will also be increased because compute and storage are tied together. And it may happen that you only needed higher compute, but you do not need higher storage. So in this case, most of your storage would be underutilized. On the other hand, in vCore model, you can see that your storage and compute are independent of each other. Normally, when you start with creating a new database in the Azure cloud, it is recommended that you should go for the DTU model. And if you are doing a lift and shift to your existing workloads to the cloud, then you should go for the vCore model. Um, This is the comparison between the DTU model and vCore model. And I have discussed most of things. There are two things that I would like to discuss here. First one is the maximum compute capacity within the DTU model. It is 4,000 DTUs, and within the vCore model, it is 80 vCores. And the maximum storage capacity in DTU is 4 terabytes, and in vCore it is also 4 terabytes. But in the case of hyperscale, you can scale up to 100 terabytes. Now, if we talk about different PaaS offerings in Azure, we have two types of PaaS offerings. As I previously explained, we have Azure SQL Database and we have Azure SQL Managed Instance. Within Azure SQL Database, we have two subcategories. We can have a single database and we can have an elastic pool. And within single database, either we can go for a provision compute and we can also go for a serverless compute. And within the Azure SQL managed instance, we can have two options. We can have a single instance and we can also have a instance pool. Currently, instance pool is in the public preview, so I will not discuss a lot about the instance pool. Just to tell you that in instance pool, um, you can what you can do is that you can pre-provision your compute resources that are relevant for your migration workload. For example, if you have an 8 core instance, you can further split it into 4 instances, which can be um, 4 core instance, another instance of 2 cores, another instance of 2 cores, and then you can move your workloads into these smaller instance pools. When we talk about the Azure SQL database, we can go for a provision compute. And in provision compute, you can scale the database if you need more storage or more memory or more processing power. And since it is a provision compute, you would be charged per hour for utilizing these resources. And in the case of a serverless compute, what you can do is that um, you will only be charged for the time when you are actually using the compute, when you are running your workload. And if your database is idle at that time, your database will go into a pause state and you will not be charged for the vCore. However, you will still be charged for the storage cost. So in the serverless model, you can actually specify an auto pause delay, which means that if your database remains idle for a certain period of time, let's say it remains idle for 15 minutes or 30 minutes, it will automatically set the status to be paused. And in this way, you can reduce the amount of money that we are spending on the compute. This is the comparison between provision compute and serverless compute. And among other things, you can see that the billing granularity is at per second when we talk about the serverless compute, and it is per hour when we talk about the provision compute. And I have previously explained that if you are going for Azure hybrid benefit or if you're going for reserved capacity license savings, these are only applicable in the provision compute. Then within the Azure SQL database, we also have an offering called Elastic Pool. And what happens in the Elastic Pool is that you actually create a pool of your resources, which can be storage, memory, and processing power. And then you have your SQL databases that are running. And when those databases need more storage, more memory, and more processing power, you can actually move your SQL databases into this pool. And when your workload is finished, you can move your database out of this pool. That is why it is called Elastic Pool. And the use case for Elastic Pool is that it is used in those workloads where your processing or where your workload processing is undetermined, that you do not know when you will need high memory. You know the period, but you do not know exactly the time duration. For example, you are running some financial systems, databases that are running some financial applications, and those databases need more power at the time when you are running your financial workloads. Maybe you're running your financial workloads at the end of the month, whereas during the beginning of the month, the workloads are not that compute intensive. So in this case, what you would do is that you will create an elastic pool, and you will move your those SQL Server instances that are running those finance workloads at the end of the month. And when the end of the month is complete, you can move your workloads out of the elastic pool. Since elastic pool is the part of Azure SQL database, so there are some restrictions that apply to the Azure SQL databases, and those restrictions also apply to the elastic pools and also to compute tier and serverless tier. That elastic pools, they do not support some kind of database constructs, and one of them is the linked servers. And I will come back to the comparison between the elastic pool and others. In Azure SQL managed instance, Azure SQL Managed Instance provides you with near compatibility with the SQL Server on premise, and since it is a PaaS offering, so you get a number of things automatically. For example, you get automatic backups, you can get automatic patching. It also provides you with with monitoring tools with which you can monitor the health status of your database. And it also reduces the overhead of managing a virtual machine because it is a PaaS offering. And SQL Server Managed Instance supports some of those database constructs that are not supported by Azure SQL database, and those are it has a support for link server, it has a support for service broker, and it also has a support for database email. If we do a comparison between both the PaaS offerings under Azure SQL Managed Instance and Azure SQL Database. So you can see that some of the features like common language runtime, SQL Server Profiler, cross database queries, database email, linked servers, service brokers, and SQL Server Agent are supported in the Azure SQL Managed Instance, whereas they are not supported in the Azure SQL Database. So if you are running some kind of workloads that rely on these features like linked servers or SQL Server Agent or database mail or a common language runtime, then it is recommended that you should go for Azure SQL Managed Instance. Now, what are the benefits of these PaaS offerings? The most important benefit is that you are free from your managing your virtual machines. You get automatic backups and automatic patches because both the PaaS offerings, Azure SQL Database and Azure SQL Managed Instance, are versionless, which means that each time Microsoft will upgrade to the newest version of SQL Server, you will get the latest version of your SQL Server automatically available in your environment. And it also provides several other features like database auditing, advanced threat protection, active geo replication, and also the transactional and snapshot replication. And it also encrypts your data, which is both encryption of data at rest, encryption of data in use, and also the encryption of data that is in motion. Now we come to the Azure SQL on a virtual machine, and this is the infrastructure as a service offering. The use case for Azure SQL virtual machine is that you are running some kind of workload that depends on the operating system, and you cannot, and it is also tied to a version. For example, you are running an application that is running on SQL Server 2016 and Windows 2016, and you want to retain the same operating system and same version of SQL Server when you are migrating to the cloud. So in this case, what you would do is that you will go for this option of SQL Server on a virtual machine. Now remember that since it is an infrastructure as a service offering, so you are responsible for operating system patching and also for optimal configuration of your network and also for the storage. In this Azure SQL on a virtual machine, you will get support for older versions of SQL Server starting from SQL Server 2008, 2012, and 2016. If you are using workloads that are dependent on SQL Server reporting services or SQL Server analysis services or SQL Server integration services, then the optimum option is to go for the Azure SQL managed instance, Azure SQL on a virtual machine. Now, if we move to the open source offerings in Azure, We have three types of open source offerings in Azure. We have Azure Database for MySQL. We have Azure Database for MariaDB, and we have Azure Database for Postgres SQL. And all these three offerings that are in Azure are based on the Community Edition. So for Azure SQL Database for MySQL, you will get Community Edition support for version 5.6, 5.7, and 5.8. Currently, MySQL version 5.6 is retired as of February 2021. But for the current workloads that are running, Microsoft is still providing the support, but it is recommended that you should move from version 5.6 to 5.7. Within the MariaDB, you have Community Edition available with the version 10.2 and 10.3. And within the Postgres SQL, you also have a Community Edition available from version 10 to version 14. So what this benefit brings us to us is that if you are running on-premise MySQL, or if you are running on-premise MariaDB, or if you are running on-premise Postgres SQL, you can actually migrate to either of these databases depending upon which stack you are using. And since these are platform as a service offerings, so you can get number of benefits like automatic patching, automatic upgrades, and automatic point in time restore with open system databases. If we talk about deployment models, within Azure Database for MySQL, we have two type of deployment models that are available. We have a single deployment, single server deployment model, and we have a flexible server deployment model. And I will come back to the details of it. And within single server, we have three types of computes that are available. We have a basic compute, we have a general purpose compute, and we have a memory optimized compute. And within the flexible server, we also have three tiers of compute, which is burstable, general purpose, and memory optimized. Now, you should remember in case of Azure Database for MySQL is that the single server is on its retirement path. So now Microsoft recommends that if you are moving your new workloads to the cloud and you are choosing the option of Azure Database for MySQL, then you should go for the flexible server um, deployment model. Azure Database for MariaDB is very simple. We only have three types of compute tiers that are available. Those are basic, general purpose, and memory optimized. And within Azure Database for PostgreSQL, we have two types of, again, deployment models that are available, which are single server and flexible server. And again, similar to Azure Database for MySQL, we have within single server, we have basic, general purpose, and memory optimized compute tier. And within flexible server, we have burstable, general purpose, and memory optimized compute tier. If we talk about Azure Database for MySQL and we do the comparison of single server deployment model and flexible server deployment model, the first thing to note is that the single server deployment model is on its retirement path. So for newer workloads, Microsoft recommends to use the flexible server. In both these options, we have a community edition that is available, and the version support is starting from 5.6, 5.7, 8.0, and on flexible server we have 5.7 and 8.0 since 5.6 is being retired now. And when it comes to scaling, the compute scaling is not supported under single server if you have opted for the basic tier. But if you are using general purpose or memory optimized tier, then you can do the scaling of your compute. On the flexible server, no matter you are using burstable, general purpose, or memory optimized, you can always scale your compute resources. Another very important feature in both single server and flexible server is that you can actually start and stop your deployments. And in single server, the server can be stopped for up to 7 days, whereas in the case of flexible server, the server can be stopped for 30 days. The SQL Server minor upgrades are supported in both the cases. And then there is an option called maintenance control, and this is very important. What maintenance control means that whenever Microsoft is coming with a version upgrade, you can actually define a window in which window your database need to be patched. For example, you can say that I want my database to be patched either on a weekend during this time schedule. So in that window, Microsoft will actually patch your database, and once the database is being patched, you will get an email notification that your database has been patched and now it is available. So maintenance control is not available in the single server, whereas in the case of a flexible server, the maintenance control is available. Um, The single server does not provide you with zone redundancy, but in the case of flexible server, you get the zone redundancy. And both these versions provide the support for read replicas. And you can get 5 read replicas in single server, and you will get 10 read replicas in the flexible server. And then number of other past offerings like automatic backups, backup retention, point in time restore are also available in both these offerings. When we talk about Azure Database for MariaDB, Azure Database for MariaDB, it is based on the Community Edition, and since it is a PaaS offering, you will get number of features available like automatic backups and automatic patching. You also have a backup retention period that is between 7 to 35 days. And in the case of MariaDB, the zone redundancy is not supported. And you can replicate from Azure Database from MariaDB to up to 5 read replicas in your environment. When we talk about Azure Database for Postgres SQL, we have two options, single server and flexible server. And in both the cases, we have a support for the community edition. And in the single server, you can have community version 10 and 11. And in the flexible server, you can have community version from 11 to 14. And when it comes to the scaling, the compute scaling, unlike like the MySQL, in the case of Postgres SQL, it is the same that compute scaling is supported, but not supported for the basic tier within the single server, and it is also supported within the flexible server. The thing that is important to notice here is that in the case of single server, you cannot stop your database server. On the other hand, in the case of flexible server, you can stop your database that is running Azure Database for Postgres SQL. And both these versions provide option for minor version upgrades. And you can also create the maintenance window. And during those maintenance window, your version upgrades, minor version upgrades would be patched to your system. Another thing that you should note here is that you do not have an option for major version upgrade in Azure Database for PostgreSQL under the single server and also for the flexible server. And what does it mean is that if you are using Azure Postgres Database for Community Edition version 10, you cannot migrate from version 10 to version 11. You can do the minor upgrades like 10.1, 10.2, but you cannot do a major upgrade running moving from version 10 to version 11. Currently, this feature is in public preview, but it is not generally available as of now. When we talk about other features that we get in cloud like zone redundancy, this is not supported for the SQL Server, whereas in the case of a flexible server, it provides you with an option of zone redundancy. You can also do an automatic failover both in the case of single server and flexible server, and the single server currently provides the read replica facility, whereas flexible server it's not possible to create a read replica, and you can have 5 read replicas in the case of a single server. And the use case for creating a read replica is that if your main workloads are quite compute and storage intensive, and you do not want to run your extra workloads on those, so you can actually create a read replica, and on read replica you can run your business intelligence applications and and create your business intelligence workloads on the read replicas. Since both the SQL Server and Flexible Server are PaaS offerings, so you get number of features that are available as a PaaS offering, like automatic backup, backup retention, and point-in-time restore. Now, previously, Azure Database for Postgres SQL Hyperscale was available within the Postgres SQL tier, but recently Microsoft has moved Azure Database for Postgres Hyperscale tier into Azure Cosmos DB, and they have rebranded it and called the product as Azure Cosmos DB for Postgres SQL. And this is a fully managed distributed Postgres SQL server that is natively built on Postgres SQL with open source extension, because Citus is actually it is an open source extension to Postgres SQL, and because it is not forked with Postgres SQL, the Citus extension will always support the latest version of Postgres SQL within the 1 week of its release. And what Citus Object does is that it actually transforms your Postgres SQL into a kind of a distributed database, so you can achieve high performance. And I will come back to the detail of it. And in Postgres SQL, you can actually scale your compute and storage that are located on different types of nodes. And currently, the supported version is Postgres SQL version 11, 12, 13, and 15. And the Citus version that is supported on Azure Cosmos DB for Postgres SQL is 11.1. And you will always get the latest Postgres SQL features in this version. So what happens in Azure Database for Postgres SQL or Citus is that you actually have two types of nodes that are available. You have worker nodes and you have distributed nodes. So here you can see that when you are creating the Azure SQL database, at the time of scale, you are defining how many nodes you want to have. Like for example, you want to have 1 to 20 nodes, or you can have 2 to 2000 nodes, and each node will have its own vCore with associated compute and storage. And since it is a PaaS offering, you will get a public URL, which would be the name of your cluster .postgres.database.azure.com, so that you can actually use this in your applications. And what happens is that when you create your instance, you can either have one-to-one configuration where you have one contributor node and one worker node, or you can have one to n configuration where you can have one contributor node and n can be 10 or 12 of your worker nodes. So what happens is that your coordinator node, this basically has all the metadata of your whole Azure Cosmos DB deployment. And then you have your worker nodes that actually contain your data. So when you create your tables, what you do is that you call this function called create distributed table, and you provide the name of the table and the column on which you want to shard your database. And sharding means that chunking, creating small chunks of your tables, and then those shards would be distributed to different worker nodes, and coordinator node will have an idea in the metadata table to which shards are distributed to which nodes. In this architecture, I have one coordinator node and I have around 12 worker nodes, and those 12 worker nodes are distributed into three clusters, and each cluster is running four coordinator nodes. So what will happen here is that this table, this is just an example of an employees table. This table would be distributed to all the coordinator nodes, all the worker nodes, and coordinator node will know which shard is available at which node. So when I run a query where I am searching for my employees, for example, within this range 5506 to 5505, this query would be run by the coordinator node, and coordinator node knows on which worker node this shard is available. So it will take the data from that shard and provide that data back to the coordinator node. So if you have very big databases that have number of table containing millions of rows, then Azure database for Postgres SQL hyperscale is extremely useful because it will provide you with distributed database capabilities, and your query time would be saved. So if we move to the Azure database for Cosmos DB, you can say that it is a database as a service offering, and it is fully managed. It is based on a serverless architecture, and it is globally distributed. And you can actually scale it, and it also provides you with multimodal and multi-language capabilities, and it is highly available. It provides you with 5 nines of service level agreement. And this database, although it is globally available, but it is built on such a robust architecture that you have less than 10 milliseconds of latency that is available for both read and write operations. And you can easily define your role-based access control roles when you are working with Azure Cosmos DB. Azure Cosmos DB also provides you with API support for connecting to different workloads. For example, it provides you with SQL API, and you can actually use SQL API to connect with Azure Table Storage. It also provides you with Table API. It also provides you with MongoDB API, and it also provides you with the Cassandra API, with the Gremlin API, and API for Postgres SQL, which is just recently being supported. So by adding Postgres SQL to Azure Cosmos DB, you can say that Azure Cosmos DB is now a kind of SQL and NoSQL kind of solution in Azure. And the data in Azure Cosmos DB is encrypted. Both the data at rest is encrypted, and also the data in motion is encrypted. And Azure Cosmos DB provides you with row level authorization, so it adheres to this security model that is created by Azure. The use case for Azure Cosmos DB is that if you are running some workloads that are running in a real-time setting or in IoT settings, then this Azure Cosmos DB can be used. For example, it can be used if you are running some IoT settings in a big telecom setup, or if you are running some kind of real-time workloads, for example, in stock exchange where you are updating the prices of the shares at the same time, and then this distributed data is being replicated to several instances. So in this case, Azure Cosmos DB can be used. And since it is based on a database as a service offering, so you do not need to think about number of administration tasks that are relevant to the infrastructure, because they will be taken care of by Microsoft. Now, there is also another very interesting capability in Azure, and this is a collaboration between Microsoft Azure and Oracle, and that is called Oracle Database Service for Azure, which is ODSA. Uh, if you compare uh, if you compare database offerings with, for example, with Amazon RDS, you will see that in Amazon RDS you can also get almost the same database offerings that we have in Azure, except for Oracle. You can get Oracle in Amazon RDS, but in Azure you do not have option to have installed Oracle instance on a PaaS offering. You have an option of creating a Azure virtual machine, and then you can install Oracle database on the top of the virtual machine. And Oracle also provides you with this option that you can bring your on-premise SQL license to the Azure. But this feature where you can actually run Azure Oracle in a PaaS offering was something that was missing in Azure. So what now Microsoft and Oracle have done is that they have moved into a collaboration, and they have created this offering that is called Oracle Data Service for Database Service for Azure. It is abbreviated as ODSA. So it is a fully managed service, and it is available since July this year. And what it does is that it allows Azure customers so that they can easily provision Oracle database services that are residing in the OCI, and they can get the Azure like experience in it. The use case for using ODSA is that, for example, your organization is running heavy Azure workloads, and you have some on-premise Oracle databases that you want to move to the cloud. And with this option of Oracle Data Service for Azure, what you could do is that you can move the Oracle instances to the Oracle Cloud. On the other hand, you can move your Microsoft applications to Azure. And with this architecture, you can leverage and use both these applications. And you will get the same Azure-like look and feel in ODSA, and you will also get a number of features, monitoring features that are available in Azure, like database matrices would be streamed into Azure Application Insights. You will also be able to use your log analytics over your Oracle database in ODSA. Um, and Microsoft claims that the latency between Azure to Oracle Cloud is less than 2 milliseconds. And Oracle database for Azure is not offered at an additional cost. There are no changes for the interconnect ports or data ingress and egress over the interconnect, and you will be billed normally for your consumption of your Oracle database services. For example, if you are using Oracle Autonomous Database. The thing that is very important to note here is that Oracle database service for Azure is not available at all the places. There is a prerequisite for ODSA, and that prerequisite is Oracle Azure Interconnect. And this Oracle Azure Interconnect is not available in all the regions, and I will come to it later. Another thing to note is that when you are using Oracle database service for Azure, customers are billed by Microsoft for the Azure resources they used, and they are billed for the Oracle resources that they would be using. And Oracle database for data service for Azure will not does not change or replace your existing contracts with Azure. So if we look into this, you can see that this is the architecture of Oracle Database Service for Azure. On the left hand side, we have Microsoft Azure, and on the right hand side, we have Oracle Cloud Infrastructure. And then on the Oracle side, we have Azure Express Route. On the Microsoft side, we have Azure Express Route. And on the Oracle Cloud Infrastructure, we have OCI Fast Connect. And then these two are connected to each other, and this connection is called Oracle Azure Interconnect. And this Oracle Azure Interconnect is needed in order for Microsoft Azure to talk to the databases on Oracle Cloud Infrastructure. And this Oracle Azure Interconnect is not available in all the regions. Currently, this feature is available is only in only 12 regions. So if you are, for example, I'm based in Copenhagen, Denmark, and we have workloads that are running in West Europe, in Azure West Europe region. So in Azure West Europe region, it has an Azure Interconnect link to the OCI Amsterdam region. So this means that in this region, we are able to run this ODSA workload by creating Oracle Interconnect for Azure between Azure instance and on the Oracle Cloud. And that was all from my side. So if you have any questions, please let me know around this.
Uh, Thank you so much, Uzair. Uh, Thank you so much, Uzair. Indeed, that was an informative session. Does the audience have any questions? Anyone from audience have any question? Okay. So, Uzair, I have a question for you.
Sure.
So, on few slides, you said that it's a serverless, right? So, can you please explain in detail when you say serverless, what does it means? Meaning, it does not have any server available, or it does have some other meaning?
Yeah, that's a very good question. When we talk about in the area of cloud computing, there is a concept called serverless. And what this serverless concept means is that, for example, let me navigate back. For example, when we talk about Azure Cosmos DB, it is based on a serverless architecture. Similarly, if we talk about Azure databases, then they are available in the Azure SQL database is available in the provision compute and also in the serverless compute. So you can see that both these offerings are PaaS offerings, which means that when you deploy these offerings to the cloud, there would be a virtual machine that would be assigned to that. Since these are PaaS offerings, you are not responsible for managing the virtual machine, and that virtual machine will provide you with the compute power and with the storage power. So the good thing in the cloud is that you can actually separate your compute and storage, which means that serverless architectures are those architectures in which you do not have a dedicated CPU allocated to you. Instead, your CPU will only be allocated when you are running a workload, which
Okay.
means that you can save money on your compute because you are going for a serverless option, which means that whenever there is an activity inside your database, at that time compute will be allocated to your database. And when that activity is finished and your database is in the inactive mode, or in the when there are nothing running in it, then your database will go to the pause mode and the compute would be deallocated to your from your workload. In this way, you will only be paying for the time where you are actually running your workload and your compute resources are being utilized. On the other hand, if you go for a provision compute where you have a dedicated compute allocated to your workload, so in this case, no matter there is an activity going inside your database or not, you will always be paying for the compute that is associated to your workload. So this type of architecture is called serverless architecture. I hope I'm able to answer your question.
Yeah, perfect. If I summarize, you mean to say, when we say serverless, there is a server behind, but that the service execute when actually the request is made, right? That's what I've
Exactly,
understood.
exactly. That's right. And this is also a concept that sometimes confuses many people who are moving to the cloud because when you say serverless, you think that there might be no compute resources allocated to it. But serverless means that although there is a compute resource allocated to it, but it will only be provoked when there is a workload running. And when there is no workload running, then compute will not be allocated to your instance. And the important thing is that in cloud, there is nothing free. And since you are moving to the cloud, companies would like to save money on wherever it is possible. So this is the reason that this serverless architecture is also available inside the cloud.
That's great. That's great. So, any other questions on the floor for Uzair? I guess no. So, Uzair, thank you so much for your time and for explaining us the about the SQL services that's being offered by Azure. Uh, Being honest, individually, I just had a in my mind that Azure service would be simply a sort of SQL Server replica, but I was amazed to see that it's not just SQL Server replica. It has more. It has so many things beyond that. So thank you so much, Uzair, for taking out time. Uh, so let's move towards our next session. Our next speaker on the floor is Komi Siabi. Are you on the call?